It would really help. Okay. So, notice that we have, these are measures of central tendency. We're talking about mean first. I'm going to illustrate the calculations of mean in 4 different scenarios. Mean, that's the mean you're used to. Weighted mean, you do that when you calculate your math marks because everything has different weights. Mean for group data, I'm going to illustrate that. Mean for group data with intervals. Okay? So, when it comes to mean, the calculations are the same for both. However, the symbolism is different. That's where it's different, okay? Notice mean for population is mu, the Greek letter mu. Mean for sample is x bar. And number of items in the population, or number of people in a population, is capital N. Number of items in a sample is lowercase n. So notice all it's saying is we add up all our values and divide it by the number of values. Okay, so the formula you need to know is this, sum of xi over n for your test. For your test, I'm happy if you just know the sample mean. I will illustrate some of the formulas for the population, but for your test, it's not necessary you know that. Okay, so weighted mean, basically you're adding up the weight of a particular mark or whatever it could be times the mark. Each one has different weights depending on how many weights you have. In math you only have what, 1, 2, maybe 3 or 4 weights. So the formula here, are you familiar with this symbol? Huh? Have you seen this symbol before? It just means add them up. Or take the sum. It's summation notation. So do you notice it's just saying add up all the weights times their corresponding mark. Alright? Sum of WYXI is the sum of the products of each data value and its related weight. Okay, now when we get into mean for group data, we're talking about frequencies within each group. And I will illustrate that and we'll write out the formulas so you get used to them. And this one is similar to this one, but now because you have intervals, instead of individual values that you're working with, you have to take the midpoint of the interval. So MI is the midpoint of the interval. So basically today we're going to talk about mean, median, and mode. Those were the mean formulas. Mean of a data set is the sum of all values divided by the number of values. And those are the formulas. I'm just reiterating that those are the formulas I want for your test. The median is just the middle value. So if you have a median, 50% of the values are below the median, 50% are above the median. Okay, so, and I'm going to illustrate when, notice there's 2 scenarios. Median is the middle value of the data set listed in ascending order. So that if you have an even number of values, the median is the mean of the 2 middle values. When you have an odd number of values, then the median will be the middle value exactly. So I will illustrate that in just a few minutes. The mode is the value or values that occur most frequency with a data set. So mode usually has fewer applications, I think. Mode is good for shoe sizes, shirt sizes. When you're a store owner, you want to see what you're selling the most of.
Please excuse this interruption. Would students in the following home forums please go to Tyson Hall for their photos? 3 Lindala, 3 Fung, 3 Thomas, and 3 Hardilea. Mr. Thomas's home forum, Mr. Hardilea
An important thing we have to consider when we're calculating mean is to determine what are outliers. If you guys, if you need to go ahead. Outliers are values that are distant from the majority of the data. Outliers have greater effect on the mean than on the median. The median is often a better measurement of central tendency than the mean for small data sets. For larger data sets, the effect of outliers is less significant. And I will illustrate that with an example, okay? Just basically, outliers have more effect on the mean than on the median, but if you have a large number of values in your sample, that is less true, right? So let's do a very simple example, okay? Find the mean, median, and mode of the following data with and without the outlier. So the first thing what you want to do is just put them in increasing order of size. Start with the lowest and go to the highest. So I will read them off and you write, okay? Just 2, 3, 5, 6, 7, 8, 9, 16. Can you tell me what the outlier might be in this data set? Yes? Yeah, notice that 16 is far away from the majority of the data, so this is our outlier. We will actually have a calculation to determine mathematically what is an outlier and what isn't. So let's do the mean with outlier. Here I'll do with outlier here. Or including the outlier. So we're going to go x bar equals sum of x, I, or I is just, notice 1, 2, 3, 4, 5, 6, 7, 8 values. So I will go x1, x2, x3, x4, x8, up to x8, right? It's just a way of just saying that these are different individual values all over n. So the sum of xi, if you were to add all of these up with the 16, is 56 over 8, and that equals 7. So that is with outlier. I'm going to do with outlier first. Let's do our median with the outlier. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. The median position first, median is a measure of position. So it tells you the value where 50% of the data is below, 50% of the data is above. So the median position formula is n plus 2 divided by 2. There's 8 values. Add 1 divided by 2 equals 4.5. So our position is the 4.5th position. 1, 2, 3, 4. It's right in between the 4.5 indicates it's right in between the 6 and the 7. So the median, we have to take the average of 6 and 7. Median is equal to 6 plus 7. You're taking the average of the 4th and 5th position over 2 equals 6.5. So our median is 6.5. What is our mode? Our mode is the most frequently occurring number. Notice there's only 1, 2, 1, 3, 1, 5, 1, 6, 1, 7, 1. So the mode is just, there is no mode. Okay? So let's do it now without the outlier. We're going to see how things change. So without outlier, we go x bar equals sum of xi minus the outlier of 16 divided by 7. So in effect, it's 56 minus 16. And that is approximately 5.7. We're going to keep a little room for a little comment here. A column, we want to see what the difference is. Maybe I'll just write difference. How did that, let's just calculate absolutely. Okay, what's our median without the outlier? Now we have 1, 2, 3, 4, 5, 6, 7, right? So median position is equal to 7 plus 1 divided by 2 is the 4th position. So the median without the outlier is equal to 1, 2, 3, 4 is the 6th. So there's still no mode. So let's look at the difference. This is down 1.3. This is down 0.5. And this is no difference, right? There's no difference here. So what we're trying to tell you is when you have an outlier, the outlier affects the mean, right? The average more than it affected the median. So in this case, the median might be the better measure of central tendency. So when we're deciding on what is the best measure of central tendency, okay, when we talk about central tendency, we're talking about mean, median, and mode. Which one is best? I don't think mode doesn't apply here. There's no mode. It doesn't give us any information when we say no mode. However, median is the best measure of central tendency when the data set is small. And there is an outlier.
Please excuse the interruption. Would students from the following home forum
So
please proceed?
notice in this case,
Mr. Stavros
the
will
median of 6.5 would be a better measure of central tendency. Not the 6, but the 6.5. Okay? Because the median of 7 is maybe overstating it a bit because of the outlier of 16. So median is median of 6.5 is the better measure of central tendency. Is that a B? Is anybody allergic? I'll kill it when I'm done. Because I'm not afraid. But I can't interrupt the video. Are we good with this? Guys, if you sit still. Hold on a sec. I have to stop this video. There's a bee in the room. Did you get him? My goodness gracious. Are we good now? Shh. Guys, you realize all of this was recorded. Absolutely. Can I elaborate on anything or explain anything? The top part? Median is the best measure of central tendency when the data set is small and there is an outlier. So in this case, median of 6.5 is the better measure of central tendency. Makes sense? Because this is a very strange, unusual value for this data set. Okay. Let's look at a weighted mean. A weighted mean is something you're used to. So the formula for weighted mean, excuse me, I don't appreciate the talking, please. Okay. Weighted mean is equal to the sum of the weight times its corresponding value all over the sum of the weights. Okay. So basically we're going 94 times 0.50. So I'm just adding the score times its corresponding weight. Then there's this project mark times 0.35 plus there's this homework mark 83 times 0.15 all over the sum of the weights. So the sum of the weights are 0.5 plus 0.35 plus, I'll put 0.15. So it adds up to 1. Yeah, you're absolutely right. So that is equal to 90.6. So this would be a mark on this student's, this would be a student's data mark. Now this was a nice case. The weights added up to 1, but they don't have to add up to 1, as is illustrated in the next example. So in this case, x bar equals sum of weights times the corresponding value over the sum of the weights. I'm not too, well, maybe let's put the subscript I, okay? Alright, so find the weighted average of two golf scores, 90 and 100. Suppose the score of 90 is to have twice the weight of 100. Okay, so 90 is to have twice the weight of 100, and it's all over 2 plus 1, which is 3. Perfect. It's about 93.3. Can I explain anything better or anything at all? Yes, absolutely. Sorry? Yeah, it's the sum of WIXI divided by the sum of WI. Should I try to write it more clearly next time? Is that the issue? So far, if you look at this, I've illustrated the mean, just a regular mean when you have individual values. Here's a weighted mean. Now let's do mean for group data. What they mean by group data is that they've just grouped similar data together. So for example, this is various demands for a hammer. Very simple example. So there were 10 days when nobody bought a hammer, 15 days when only one hammer was sold, 12 days when 2 hammers were sold, 18 days when 3 hammers were sold. So basically what they're saying is our individual X values are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because we have 10 days when it was 0. And then there's 15 days when it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is just summarizing all of that within the table. I'm just going to go a little further because it will help us in a subsequent calculation. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, etc., etc. Okay? So this is what the table is representing. Instead of writing it out like this and adding all these numbers, we can simplify our calculation. So in this case, x bar is equal to the sum of xi fi all over the sum of fi. The sum of our frequencies. Because the sum of our frequencies is equivalent to n, right? The total number of values. Right? Okay, so now let's calculate it here. 0 times 10 is 0. 1 times 15 is 15. 2 times 12 is 24. 3 times 18 is 54. 4 times 6 is 24. 5 times 4 is 20. So the sum of Fi xi is equal to 137. So let's calculate the mean, median, and mode. First we'll do the mean. Thank goodness we have this value. That's 137 divided by 65, and that is approximately equal to 2.1. So we can say on average about 2.1 hammers are sold. Per day. Okay, so on average you're selling 2.1 hammers a day. I like to buy a certain bag of vegetable at Walmart, believe it or not. And I was complaining that they don't keep enough stock of this vegetable because it's my most favorite frozen vegetable. And they said the reason they do that because on average they only sell one bag per day. So I ordered 2 boxes. And I bought 24 all at once when they came. It's a Tuscan vegetable that I really like. Can you hide that cell phone or I will hide it for you? Can you get rid of it? Thank you. Okay, now let's do the median. The median position is equal to n plus 1 divided by 2. 65 plus 1 divided by 2 is going to be the 33rd position. Now I could count 33rd. I could go 1, 2, 3, 4, 5. That's 10. 11, 12. Well, 10 plus, that's 25. 26, 27, 28, 29, 30, 31, 32. Oh, I lost it. Hold it. 25, 26, 27, 28, 29, 30. It's there. Right? Oh, the 33rd? 25, 26, 27, 28, 29, 30. Okay, so it's not that one, it's this one. Fair enough? So the median is the 33rd position, but I notice that I have 10 here. This is 25. I know, and this is 37, so I know that the 33rd position is 2. I could just look here, right? I can just look here. That's the 25th. That brings me up to 27, so 33 falls in this interval. So you could say the median is equal to 2. Oh yeah, in this case we can just say that. I was thinking of this situation. On average, 2 hammers are sold per day. if we use the median as our measure of central tendency. And what is our mode? The mode is the most frequently occurring demand in this case, so our mode is 3. More often than not, they sell 3 hammers per day.
Please excuse the interruption. Would students from the following home farms please proceed down to Titan Hall for photos? For Wong, for Yonker, for Jangarus, for Chang. Students in those home farms, please proceed to Titan Hall now.
Okay, sorry? Well, it's the formula that works. The only way I can illustrate that for you with the smaller example. It's just basically it's what works. So if I have one, the middle value in 1, 2, 3, 4, 5, 6, 13. Can you see that the middle value is that's 3 below, 3 above, that's our median. So if I just go, the position is 1, 2, 3, 4, 5, 6, 7, is 7 plus 1 divided by 2 is the 4th position. Can you see that it's basically what works, right? And then if you have an even number of values, then you're going to go 8 plus 1 divided by 2. It's the 4.5th position, so it's going to be 8. It's just what works. Yeah. It helps. I think this formula, I mean, if you just have a small number of values, you just can count, right? But if you have 60, 90, a million values, and the formula comes in handy. Okay, a record of John's cell phone numbers per day is given in the following table. Calls per day. Notice now this is group data. Here it was grouped, but this is group data with intervals. We have 12 days where he got 0 to 2 calls, 8 days where he got 3 to 5 calls, 3 days where he got 9 to 11 calls, etc., etc. Now we don't have individual values like we did up here because of intervals. We use the midpoint. It's not exact, right? It's our best estimate, right? We don't have, like this is a more exact calculation because we have individual values. But here we have intervals. It's not as exact, but what can we do? We're giving it our best shot, right? So the midpoint is 0 plus 2 divided by 2 equals 1. We're going to use 1 to estimate the major value between 0 and 2. 3 plus 5 divided by 2 equals 4. And then we'll just calculating the rest of them. Okay, so now we're going to calculate. Notice our formula now becomes the sum of our midpoint times the frequency of that midpoint all over the sum of our frequency. So if I were to add these up, sum of Fi is equal to 30. And now we have to calculate this, 12. So this, as you know, is not rocket science. It's just very simple calculations that you need to see. When you do your project, Excel will do this for you, right? You don't have to do these tedious little calculations, but it's important to see what's involved while you're just learning. So the sum of this is 138. So x bar is equal to 138 divided by 30, and that is approximately 4.6. So on average, John had 4.6 calls per day. So let's calculate our median position. I'm just going to put it over here. Median position is equal to n plus 1 divided by 2. Okay, so we have equals 30 plus 1 divided by 2 is the 15th position. So here's I have 12. Here I have 20, so 15.5 falls between 3 to 5. So you can either say the median is approximately 4, or you can say the median interval is, 3 to 5. And similarly for mode, you can say the mode is, what's our mode? Yeah, and the mode is 1. Yeah, or you could say modal interval. Whatever you decide to do. I mean, as a researcher or anyone who's studying their, looking at their data in a company, their sales, their costs, whatever, you'll know what is the best measure for you, how you want to best express it. But yes. Oh, what do you mean, like 0 to 3? Then you approximate. See, the thing about stats, that's a very good question. Let's say your intervals are like 0 to 3, 0, 1, 2, 3, 4, 5, 6, 4 to 7. So you're going to go 0 plus 3 divided by 2. You could leave it at 1.5. You could approximate it as 2. You're just eyeballing. I personally would just approximate normally, right? Just the way you normally do if this is 5 or up. You could leave it at 1.5, you could round it up to 2. It's just that all of this, the purpose of this is not necessarily exact values. The purpose of this is to get an overall picture, right? Because really, none of the decisions you're doing here is a matter of life or death. It's just to give you a rough, if it's a matter of life or death, you want exact numbers and good approximation. But when you're trying to decide how many hammers to purchase, this is good. Rounding up is good enough. Probably better to round up because you want to have your supply there in case, your sales exceed. But if you buy too many, what does it matter? You'll sell it the next month. Right? There's not a life and death threatening situation. So that's the thing about statistics. It's not really an exact science. You're trying to just get the best info you can. Any other things I can elaborate on? Yeah.
How many decimal places do you want?
I'll say on a test 1. Yeah, it'll say on the test. If I don't tell you, you just decide. If I don't tell you, I can't take marks off because I didn't tell you what to round it to, right? Yeah.